is that if your function is the variable, the base x, to some power, then its derivative, and remember we had that little shortcut notation with the little, we call it f prime, the derivative is equivalent to the old power now is a coefficient multiplying x, and the new exponent is 1 less than the exponent was before. Okay, and we will do a bunch of examples, so at the moment I'm not going to do a bunch of examples, but I'm just pointing out, you'll hear people say the power rule for derivatives, that's what they're talking about. And that was the one that we proved, and I think that was the only one we proved, right? If I remember right. Okay. We've talked about the derivative of a constant. Maybe you didn't notice, but if your function is a constant, okay, let's first just think about it in terms of the definition of a derivative. So that means like y equals 7. Okay, if y equals 7, then y is always equal to 7, and your graph is this horizontal line. And what is the slope of a horizontal line?
0.
It's always 0. So the derivative of a constant is 0. And that was part of question number 3 on your quiz, was what are the 3 times that a derivative will be 0? Well, one of them is if your function's constant and it's all flat, then your derivative will be 0.
Bless you.
If you tried to do a limit proof of that, again, I'm just going to do the f of x minus f of a version. So f of x is c, f of a is c, and so my numerator is always 0 for any value of x minus a. So if you try to analyze that, that is going to 0. I think it's easier to just think about it from the idea that derivative is supposed to be measuring slope. So just look at the picture, my slope is always 0. Okay, so that's this rule. And now for sine and cosine. I think I'll dim our... Okay, we will look at this graphically, but let's kind of go back to our algebra proofs. We're finding shortcuts for instantaneous slope, and there's different ways we can express that. Slope in general is y1 minus y2 over x1 minus x2. So if this is my special x that I particularly want the slope at, this is representing any other x value, and if we take the limit as those x values are getting close to, infinitely close to my special value, then that's creating the idea of instantaneous slope. Another popular way to write this limit down is to let x minus a just be a single variable, and h is usually the letter that they use. And so if I replace x minus a with h and rewrite that same thing over there, h would be going to 0, because if x is heading towards a, then their difference is heading towards 0. And in the denominator here, I would have h, and then I would just leave this f of x, and if x minus a equals h, then x minus h equals a, I guess. I don't know, you could always write it around. Usually they put the x plus, h in the front part of it. I'll write it the way that they usually have it written, but.
I won't write
Okay, so this is representing the difference between x and a. If x is going to a, then that difference is going to 0. So this statement is saying the same thing as this statement. They both say the same thing. All right, the benefit of this form is that it looks a little more directly like y1 minus y2 over x1 minus x2. So when you're trying to keep emphasizing the idea that derivative is slope, or calculating slope, that looks more like it. The benefit of this version is that when you get done, you end up having x, you have x in the formula, whereas you're going to end up with a in the formula with that version, but it's not a big deal because a is just representing some x that you're interested in. Okay, if you do this version and then you want to use it, you're going to plug in some special number for x anyway. Okay, so that they are both are saying the same thing. Your book talks about both versions. I suspect in their proofs they write this one out more often than they do that one, but at least the older versions of the book, I'll admit, we've used this book for so long, it's been a little while since I've read that particular section, but I know that they talked about both versions. So I'm just mentioning both because if you get online or you're talking to people in the ASC, other people, they're just used to this version, so they're going to go to it first. Again, that's fine. They both say the same thing. They both, in the long run, get you the same place.